So thank you very much for coming. If you have any questions, just type them in the chat as we go, and I will take a look soon. So this is a session for hacking Android and iOS applications using Deep Links and XSS. It's a free workshop. And also they're recording the slides and all the vulnerable applications that I'm going to demo today. This is all available for free on the training portal. So we will do a quick introduction about what the course is about because we have a live online session next week. So I'll give you a bit of details about that. And then we will talk about Deep Links attacks, achieving user impersonation and bypassing authorization controls, and Deep Link attacks to make phone calls, right? So a couple of very interesting scenarios. Then we will also see XSS attacks and data exfiltration on both Android and iOS. If you have a question, just type it on the chat. I'll get back to you in a moment. So I'm Abraham Aranguren. I'm the CEO of 7E Security. So if you like this presentation, there's some public Pentest reports and other stuff on the website. All available for free. We have delivered training at Black Hat USA, Hack in the Box, OWASP Global AppSec, NullCon, and many other well-known conferences. So if you want to know where we will be teaching next, you can check our training page there on the website. And for reference, I don't make any money out of this course anymore. But I also wrote a course for e-learner security called Practical Web Defense, which was about hacking web applications and then fixing the bugs so that the issue was no longer exploitable, right? So it was a nice attack and defense kind of course. I'm also one of the project leaders for OWASP OWTF. So if you type owtf.org in your browser, that will take you to the OWASP page. This is a link to some presentations that I have delivered, and if after all the pandemic we meet someday, I can explain to you how all this certification stuff happened, which is a bit funny. So on the website, you will see a lot of Pentest reports. Some that got a bit of media attention are the following, right? So the first two reports here are about Smart Sheriff. So this was so broken that we even gave a presentation about it. So it was a mobile application mandated in the entire country of South Korea. This is the good Korea, not the communist one, but the supposedly good Korea. And in this country, the government somehow decided that all parents and all children should have by law to install an application. Where the parent would control the child, what applications they can have installed, during what times of the day the phone can be used, and all that kind of stuff, right? So, a typical political idea to if you want to get something approved in politics, you have to save the children. So this was, the story with this. And then on the Pentest reports, you can see the first time that we tested them, and then the second. And in this presentation, you can search Smart Sheriff in YouTube, and you will see a few talks that we delivered. It was really, really broken. It's catastrophic. And yeah, so this is more about mobile security. And then the Chinese government and surveillance and all these kind of apps, these are more kind of privacy related, right? So the context here is there's a Muslim minority in Xinjiang. And then there were some concerns from human rights activists about whether the applications were collecting too much data about citizens and whether that would be a human rights violation or not. So we just did the technical stuff, just looking for vulnerabilities. I'm trying to answer the questions from the human rights activists about finding evidence about what kind of information was being collected. So these reports are more privacy related. And if you search on YouTube, Chinese police and cloud pets, I also delivered a talk about this if you want to learn more about it. And if you join us for the live training this week, all these applications are also available inside of our mobile course for your entertainment. So yeah, you get to play with all these applications as part of the full course, right? And there's a lot of other public Pentest reports. All the Pentest reports are available for free. You can download them, and it's a great way for you to learn about mobile security, right? So reading Pentest reports, what other applications did wrong, how the exploit worked, and all this kind of stuff can be really useful. So yeah, in this course, there's also Anirudh Anand. So he's a member of the Team BIOS team in India. So it's the number one ranked CTF team, has some certifications. This is his blog and his Twitter. Also, there's a couple more people involved in this course, like Juan and Abby, but we have to change the slides for that. And yeah, if you take the course, we recommend that you have the following. So ability to connect to wireless and wired networks, so typical stuff. Ability to read PDF files. Now, administrative rights, this is more about importing VMs and things like this. Sometimes people come with a corporate laptop, so they cannot do certain things, and this is a problem during the class. So try to have a laptop where you have more access. If you have 8 gigabytes of RAM, that should be plenty. If you have 16 or more, that's even better, but with 8, you should be good. And 60 gigabytes or so of free disk space would be good. For the Android part, it's good if you have VirtualBox installed, because we will be using Genymotion, as I will be using for the demo today. And Genymotion uses VirtualBox under the hood. So having VirtualBox and the VirtualBox extension pack, this would be helpful. And then, yeah, having Verb, Zap, or Fiddler, some tool to do some man in the middle, that would also be helpful. Now, in our courses, the first 4 things are kind of the standard, right? Digital copies of all training material, lab VMs, test apps, and source code for the test apps. So this is kind of normal. And what we do a little bit different is this, right? So lifetime access to training portal. So I don't like when you buy a course. If I buy a course, I want to have it forever, including all future updates for free. So that's what we did in cybersecurity. So all our courses, including this workshop that you got for free, you have lifetime access to it. So if we update the workshop, if we add more demos, if we add more apps, you will also get these for free. You also get step-by-step video recordings, slides, and lab PDFs, and unlimited email support, right? So just to mention that. And then I'm just going to very briefly talk about what we cover in the full course. And then while I do that, I will tell you what we are going to talk about today, right? So the first part is hacking Android and IoT apps by example. So we start with understanding Android with Termux. Termux is a really cool tool because it gives you a shell, so we can try to read all the files from other apps and see what happens. So it's an easy way for you to understand how the Android security system works. So we cover a bunch of things about there. And in lab 2, we talk more about reversing and source code analysis. I'm going to move my face a little bit down. Typical reversing, like compiling APKs, what to look for, some automated tools, some manual methods, very interesting stuff. And also here we also show you like how to do code reviews, what to look for, and how to look for vulnerabilities. And then in lab 3, we cover browser and other things, right? So this is a really cool lab. This is one of the labs that people like the most because this is all about attacking, right? So here we attack all the attack surface with browser, like attack activities, content providers, services, you name it. And then here we also have a part about attacking deep links in Android. So today we will be doing this demo here. Now this is a shorter version than the one in the course, and I will rush through it a little bit today because we only have about an hour. But about deep links, we have 2 case studies, right? So one with Periscope and another with Shopify. So with Shopify, we have a nice fingerprint bypass. And with Periscope, there's a cross-request forgery using a deep link, which is also cool. And this one I will show today. And then we also have nice attacks about WebViews. So how to get XSS on a WebView, and then what can you do with these XSS, right? So in some scenarios, you can exfiltrate data. So we will see a little bit of this today, right? So today, a little bit of Periscope cross-request forgeries with deep links, and a little bit of XSS and data exfiltration in Android. Right? So we will do a bit of, to showcase a little bit of the course, these 2 parts here. Then in lab 4, we talk about man in the middle, right? How to set it up, how to bypass certain things, and so on. Lab 5, we talk about repackaging. So if you have an application, ways in which you can modify it. For example, if you don't have root, how can you modify an APK to still get some decent level of access and be able to review files of the application and so on, how to bypass root detection checks with repackaging, and a lot of cool exercises like this. And then in lab 6, we talk about Xposed, another method for instrumentation, right? So brief introduction to Xposed, and then we cover some Xposed modules to do a lot of really cool stuff in real time and modify as well the application in real time. So really nice stuff. And then each day it finishes with a CTF, right? So everything I've said until now, this will be part of the live training next week. And then the iOS part, if you get the full course, then this will be part of it, right? So this is the second part of the full course, but for next week it will be only Android, right? So we will only be doing the Android part. So in iOS, we talk about the jailbroken setup, iOS fundamentals, and a lot of things like this, how to transfer files, how to jailbreak your device, and a lot of things like this. Then we talk about IPA decryption and black box analysis. So if you don't have the source code, what can you do? How can you look for vulnerabilities? How can you decrypt IPAs from the App Store, and so on. In lab 3, static code analysis. So we look in cases where you have the source code, how to look for vulnerabilities. We show you some examples from real Pentest and some automated techniques to look for vulnerabilities. Lab 4 with man in the middle in iOS. And some very interesting scenarios and useful tips for you for real assessment. Lab 5 is similar to the repackaging on Android, so we modify iOS applications at rest. So we unpackage the application, make some changes, and then install it again and see how the application changes, right? So here we do not only cover the normal iOS applications written in Objective-C or Swift, but also the some exercises about modifying applications written in JavaScript, right? With Apache Cordova, for example. There's other platforms that allow you to write JavaScript applications for Android and iOS, for example. Cordova, Ionic, PhoneGap. Then there's also React Native, and others, right? So there's a lot of frameworks like this. And then in lab 6, we talk about the instrumentation. So lots of things about the instrumentation. Maybe I'll show you a little bit of Flex today. And yeah, so that's pretty much it. Yeah, and today I forgot to mention this. So today we will see some of the XSS in here and something about attacking URL handlers, right? So today we will cover a little bit of this and a little bit of this. Of course, in the course, everything is explained in much more detail, but we only have time for so much today, right? And at the end, there's some CTF open challenges, applications, interesting applications from real Pentest, and we also have scenarios for testing applications that control some IoT devices. And then it's very interesting how you can find vulnerabilities in the IoT device without having the IoT device by only looking at the mobile app. So with this, now we're ready to start with the actual content of this workshop, going into detail about all these attacks. So question for you, does cross-site request forgery exist in mobile apps? What do you think? Can we get the link for all PDF mentioned in the slides? Yes. So you have, when you access the training portal, you will have access to all the slides. And you can click on any link, but also the PDFs in the slides, you can see them on the website as well. So if you go to 70security.com, you can see there all that. So yeah, with deep links, this is a very good answer. So with deep links, we have the possibility to have the equivalent of cross-site request forgery, right? So this is correct. So let's talk about it. Right? So deep link attacks achieving user impersonation are some of the things that we're going to see, and then we will also see deep link attacks to bypass authorization control. So mobile deep link. So how does this work, right? So a deep link is basically a URI that can be used to navigate to different parts of an application. So these are available on both Android and iOS, and they can have, but do not have to have custom schemes, right? So the can here is kind of important. So, for example, a social media application could register a social app / homepage kind of URL, right? And then any click to such link will be automatically opened in the application. So what's the deal with this, right? So you can, for example, have an application that has social app / profile, or social app / profile picture. And then, like calling different things like this, you can sometimes perform some actions. And in some cases, for example, in the case of the Shopify fingerprint bypass that we have in the course, what happens is you leave so the application locks itself, and then it requires you to enter a fingerprint. But then if there's some deep link, sometimes it's possible to invoke the deep link, and then this will bypass the fingerprint check, right? So there's something like this in the Shopify bypass that we won't see today. Today we will talk about Periscope, but I'm getting ahead of myself. You did now. So how do deep links work, right? So the first thing you need to do is to look at the Android manifest. And here we want to look at the activities. So here you will notice that this activity doesn't have the word exported, right? So activities can be explicitly exported, and that would be when you have the exported word here. In this case, we don't have exported, but we have an intent filter. So when you have an intent filter, this is the same as having exported here. And specifically, this is saying how this activity should be invoked. So in this case, we have an activity called deep link activity, and we have some specification about what the application expects, right? So the Android scheme is some app, the host is get creds, and then the path prefix is user, right? So this means the URL, if you send this application a URL like this, like scheme host path, following this nomenclature here, this means that this application will have a deep link like this, like some app / get creds and user, right? So this is what this is telling you. And then there's the possibility of the deep link being browsable, right? This is not required, right? You can still attack deep links when they are not browsable, but if the deep link is also browsable, then things can get even more interesting because the attack might be possible as well through a website. Because this means that from the Android browser, if you click on a deep link on a web page on the internet, that can also call the mobile app with the deep link, right? So we will see this in the demo today, and it will make more sense. But just to mention, this is not required, but it extends the attack surface, right? So without browsable, this deep link can only be attacked from malicious applications installed on the same phone. But with browsable, the application can additionally be attacked from the browser, right? So not just malicious applications installed on the phone calling the deep link, but also malicious websites. When the user clicks on anything, they can also call the deep link if you have the browsable thing here, right? So browsable browser. So that's a quick way to remember it, and that's what it means. So let's talk about Periscope. So Periscope is an application that has a bunch of users. Unfortunately, Twitter is going to kill it this year. So we will modify the APK so that it keeps working and the exercise keeps working. So we are working on that. So the best is when you download the slides, just use the APK from the training portal. Because this is the specific vulnerable version affected by the deep link vulnerability that we're going to talk about, right? So if you get the latest Periscope application, this won't work. You need this exact version. And in the training portal, we will also modify it so that the exercise keeps working despite Twitter killing Periscope. So this application has a lot of users, and it was vulnerable to a cross-site request forgery using deep links, right? So first, would need to create a Periscope account. Now, this may no longer be possible, but we will get around it in the modified APK. And then the first thing you need to do is to look at the Android manifest, right? Like which are the activities being exported and how to call these deep links. So you run, for example, APK tool, and you decompile the APK, and you will get some output like this. and then you can start reading the manifest, right? So you open the Android manifest and you can look for browsable activities, or you can just look for Android scheme and look at the intent filters. And this will show you all the possibilities to call the Periscope application, right? So in this case, we can see there's a lot of possible Android hosts. You can see Periscope TV, user, broadcast channel, discover, Android scheme, PSCP, right? So there's a lot of different possibilities. Now, very interesting is this thing here, right? So I mentioned before that deep links do not necessarily have to have a custom scheme, right? So in this case, you can see you can have PSCP : but you can also have HTTPS : periscope.tv, and this will also be called be opened inside of the application, right? Because this Android manifest is telling Android that this application can handle these URLs. So Android will give you the choice of opening this link, HTTPS link, in Periscope, right? So you can have deep links with HTTPS or HTTP, like URLs that look like normal URLs you would use on a website. You do not necessarily have to have a custom scheme. Okay, so just to mention that. Yeah, so in this case, we can take an existing user on Periscope. We will use this user as an example, and this is how the deep link works. So you can have PSCP : //user and then the ID of the user. So one possible approach is to use Deep Link Tester, which is a mobile application. You can get it on the training portal, right? So all these things that I'm saying, you can get it on the training portal. You just log in. So everybody in this call got an invite. If you didn't, because you're watching the recording, you can get this workshop for free on the store as well. And you basically download the version from there. You can try this, right? So this simulates a malicious application calling the deep link, right? So with Deep Link Tester, we can type here the deep link that we want, and then we can go to URI, and we will see that the profile of this guy appears, right? So until now, we are still not doing anything dangerous. We're just opening the profile. We can also do this with ADB, right? So ADB is my favorite. When you talk to developers or you are writing a Pentest report, you should always strive to use ADB, right? Because the Android developers that are going to read the Pentest report and eventually have to fix the issues, they will know ADB, right? So if you give them an ADB command, they will be able to replicate what you found very easily because they can run the command, right? So you should not use Drowser in your Pentest reports because unless you have to, right? Like there's some scenarios where Drowser can send intents that are more cumbersome to send with ADB. But if you can, it's always better to use ADB just because developers have it and they are familiar with it, right? So you can do ADB shell and then AM start, and then this is the intent action, right? So -a is the action of the intent, so Android intent action view, and then the data of the intent is the URL, so PSCP : //user, and then the ID of the user. So that's another approach. And then another possible approach is with Drowser, right? So Drowser is a very powerful tool. You should first run the Drowser application on the phone, and this simulates a malicious application installed on the phone, and then you can control it from your computer, right? So from your computer, you connect to the device, and then it's really nice because it has a scanner for checking browsable activities, for example, as well as other scanners that we cover in the course, right? So in this case, we can run the scanner for browsable activities, and then this is the ID, the package name of the Periscope application. So this will give us some information about browsable activities. Now, you will notice that the invocable URLs, URIs like this list is very poor and very short. So this is a nice starting point, but it is no replacement for looking at the Android manifest and seeing all the combinations, right? Because there's really a lot more combinations than these URIs. And you will see these by looking at the Android manifest and looking at the source code and thinking, right? So Drowser would only take you so far, but it can still be a very good starting point if you don't know anything, or at the beginning of a pentest, just to give you something. It can still be helpful, but it's no replacement for manual assessment and looking at the Android manifest and looking at the source code and thinking, right? So just to mention that. And here in Drowser, we can just run activity start and action, and same action as before. So Android intent action view, and then data URI is PSCP user, and then the ID of the user. So this will also open the profile. Now, because this activity is browsable, the fourth option that we have to invoke this URI is from a website, right? So from the slides, you can click on this link, and you can open this link on the browser in Android. And this will have the proof of concept that you can use from a website, right? So that you don't have to host it yourself. So if you want, you can open this on the browser using ADB like this. So you can do ADB shell and start Android intent action view. And then on the data, you put this URL, and this will open it in Android. If you want to, copy and paste, or you don't want to type the URI from your phone, which is messy, you can do it like this. So this will look something like this, right? So you have the option to open the user, and this will open the user profile. And you can see there's a follow button, but we're still not following the user, right? So we open the user, and this just shows the profile of the user. So then we can add the /follow at the end, and this will automatically follow the user, right? So this is actually the cross-site request forgery vulnerability, right? Like just opening the profile, this is still not a vulnerability, but the fact that you can follow anybody without any user prompt or any form of authorization, this is the issue, right? This is an impersonation where we are abusing the trust that the user has on the application. And then when this is opened in Periscope, the user will be automatically followed without any more user interaction other than clicking on some link, right? So with Deep Link Tester, we only need to add the /follow at the end. And you will see the following here. And then with ADB, we just add the follow like this. And then with Browser, we can do the same thing as before and just add the /follow, right? So in all cases, or from the website, you can click on Periscope Request for the demo, and you will see that you follow the user immediately without any other interaction, right? So this is the vulnerability. So yeah, so that's how it works, and this is the HTML from the site, right? So this is the just to open the user. This is just a normal link like this, and then to follow the user, we have the same, and then at the end we add the /follow, and this automatically follows the user, and this is actually the cross-site request forgery. So that's the link. So to mitigate these kinds of issues, you should try to have some prompts to the user, right? So when the user clicks on a link like this before following the user, you should ask the user, like, do you really want to follow this guy? And then the user will say yes or no. So if you are a developer, that would be the way to fix it, right? So with this, let's start with the demo. Now this is a live demo, so fingers crossed. Yeah, so this is Periscope, right? So first, I'm going to do the ADB. So I have here ADB, right? So I can do ADB shell and try this. So I'm just going to copy this for later. So if I hit enter on this, and now I look again at Periscope, we can see that the profile of this guy has been opened. So we are opening the profile, right? And now if I do the same thing, and I add follow, now I go back here, you can see that now I'm following him, right? So there was no other user interaction, right? So I'm following, right? So not following. Now you have to click on something because then it doesn't work. And now here, if I do this again, you can see that the request forgery worked, right? So now let me see if I have here Deep Link Tester. And now hopefully this will work. If I can paste that. Okay, so it worked, but not to worry. So, okay, so I'll just type it. So PCP and then user mkbhd. So if I just go to URI here, you can see that again I'm opening the profile, but I'm not following him. And then if I go back to Deep Link Tester, and here I add /follow, and I go to URI, this would be another way. Now, in this scenario, it would be a malicious application installed on the phone, which is what we simulated before with ADB, right? So now I'm unfollowing again, so not following him. You have to click on something so that the user is not displayed. And now let's look at browser, right? So in browser, first we can run the browsable. Okay, so I have to start browser again, and here we can run the scanner first, right? So we can run scanner activity browsable of the Periscope tv.periscope.android, and this gives us the different URIs as I showed before, right? Now this list is very poor, right? So if we look at the Android manifest here, and I go to filter, you can see that it's really, so here we have an Android scheme of TV Periscope Android. So do you see that here? There's no TV. Oh, okay. So this one is here, right? So, but there's others that won't be, right? So if I keep looking for intent filters, there's really a lot. So here, for example, we have an HTTPS and different hosts. So browser is not computing like HTTP Periscope.tv, HTTP PSCP.tv, all these, it's not doing all the combinations. You have to think by yourself, right? So here you have some of the combinations, but not all, right? So for example, if you look at this intent filter, this shows you that, for example, HTTPS and www.pscp.tv, this would also be a way to call this uprouter activity, right? So with www.pscp.tv, but if you look at browser, that one is not here, right? That combination, whereas it's really one of the possible things, right? And this is actually a browsable activity, which is the only activities that browser is looking for, right? So we are running the browsable activity scanner, right? And it is failing to find some of the combinations, right? So again, browser not a replacement of doing this manually. It's always better if you think by yourself, right? So you have 2 valid schemes, 4 valid hosts. This means there's 8 possible, right? So 2 by 4, 8 possible deep links on this browsable activity, right? To call this browsable activity. So browser is not going to give you all the combinations, but this can still be a decent start. So now let's run this. Let me move my somewhere else. So here I'm going to remove the follow just to open the profile. Now I minimize this and open browser. You can see we are not following him, but it opened the profile. Now the profile is minimized. If I go back here and I add the follow, you can see that we are following the user, right? So I'm following. Now I go back and follow. So we are following him, right? So this is the cross request forgery demonstrated through Drosser. So one of the other techniques that we see in the course. And now let's do it from a website, right? So in here I can open the user. So this will just open the profile. And you can see this, right? And then if I minimize this and I go back to the website and I do the follow, now, of course, in a real attack, this would not say Periscope cross-site request forgery demo. This would say win an iPad now or something like this, just to entice a user to click on that, right? And then when the user clicks on it, you can see that we are following the user, right? So the fourth possibility from our website, right? I'm going to do it again just to demonstrate. So if I click on the follow, you can see that I am following him, right? So this is the end of the Periscope cross-site request forgery demo. We talked about the mitigation as well. So now let's talk about deep attacks to make phone calls, right? So this is an abbreviated version of finding and exploiting URL handlers in the course. So for this, it's better if you use always the applications from the training portal, because they are the exact same version that we used as we wrote the course. And maybe this application changes later if you get it from the internet. So always try to get the ones from the training portal for best results. And for this, again, you just log in and download the slides and then click on the links from the slides while you are logged in, right? And then this will work just fine. But that's how it works, right? So from the slides, just click on the links, and this downloads the applications from the training portal. So first, we need a way to find and exploit these URL handlers, right? So in Android, we had to look at the Android manifest. In iOS, the equivalent is the info plist. So there's different ways to do this, right? You could try to, extract the IPA if you get it on a computer and then looking at the info plist. You can also look at the info plist from the phone, which I will show. And then inside of here, you can look for URL schemes, right? So this will be the case for deep links that are using a custom URL scheme, but always remember that deep links can also be without a custom URL scheme, right? So in those cases, it will be some HTTPS and the domain name. And then when you click on that link, this will be opened by the iOS application. In fact, if you are a developer, you should not do this because this is considered insecure because other iOS applications installed on the phone could also register the same URIs, and then they could capture some of the requests that your application should capture instead. Like, for example, credentials is if a user is trying to log in and you have a URL handler to handle the token from login through Google, for example, that will be bad, right? If another application hijacks your scheme, right? So you should not do this, but you should, if you are a pen tester, you should look for this, right? Because this can give you some hints about potential attacks through deep links. So in this case, we have a couple of URL schemes. So dump vulnerable insecure app and dump vulnerable insecure at Swift. So both schemes will work. So this is the way to look for this in the info list. If you have the source code, you can also check this through Xcode. So you would click on the source code, and then you go to the info tab, and then you scroll down, and there's URI types. And to the right of this, you will have something called URL schemes, and this will also tell you which are the custom URLs that the application is using. So this means that the application uses these two possible URLs, right? So dump vulnerable insecure at Swift and dump vulnerable insecure app, and both will be opened by this application, dump vulnerable insecure app, right? So now the question is, okay, we know if you click on this will be open in the app, but what can we do with it? So to answer that question, we need to look at the source code, right? So the first place you should look at is the app delegate. If the application is written in Swift, this will be called appdelegate.swift. If it is written in Objective-C, it will be appdelegate.m, right? So .m for Objective-C. Now, most applications nowadays are written in Swift, but there's still some written in Objective-C. So, but just look for appdelegate, and this will point you in the right direction, right? So if you don't have Xcode, you can just find and then appdelegate.swift, and this will give you the location of the file. In this case, you can see the logic here, right? So this is function application, the logic to open a URL. So this is doing a split, right? So URL absolute string component separated by phone call number. So if you're familiar with Python, this would be the equivalent of doing a split based on this string. Or if you are you're more familiar with PHP, for example, this would be the equivalent of doing explode. So you can explode on a string, and then this will give you an array. So this is the equivalent of that in Swift, right? So they are basically looking for phone call number in the URL, and then they are splitting this into chunks. So because in computers, everything starts with 0, right? The first chunk of the array will be 0. And then the second part of the array, whatever comes after phone call number, so the actual number, this will be in the position number 1, right? So here we have a check. So it's basically checking if this is a number, if you can cast it to integer. And then if this casting is successful, it says, okay, this URL is valid because the phone number is an integer, so I'm just going to make a phone call. right? So this is all the logic here, and this is a very interesting attack vector on mobile applications because it's not just about impersonating users, but also if you can get the phone to make a premium phone call, then this can also be a good way for an attacker to make money out of an attack, because you can make a premium phone call and then the attacker gets money from this call, right? So this would be without having Xcode, just opening that in some editor. And if you use Xcode, it's basically the same thing, but here you would navigate to this appdelegate.swift, and here you would see the source code like function application, and then this is doing the split, and this is cast into integer. Everything else is the same, right? But this is how you would look at it, and this is the nice syntax highlighting with all the pretty colors in Xcode. So with this, now we know the format of the URLs after looking at the source code. So you would also have to do something like this with Periscope or other applications. You also need to, for example, to find that /follow that I showed before, you would also need to look at the source code and understand it to figure that out. In this case, it was very easy to see this in the app delegate. So this tells us that the URLs are something like this: then vulnerable insecure at Swift, phone call number, and then the actual number, or then vulnerable insecure phone call number and the number here, right? So if we click on these links, they will be opened in the application. So if you click on this link from the slides, ideally you should open these links from your phone to test this. You don't need a jailbroken phone actually for this exercise. So if you just have an iOS device and it's not jailbroken, it will still work. And then you just open these and click on the links and you will see what happens. So this is the HTML of this page, right, that you can open in your browser. And then this is just showing the entire URL so that you know what you're doing, which is useful for a demo. But of course, in a real attack, this would say win an iPad now, click here to get this much money or something like that, right? So something you want the click, so you will have like some text to entice the user to click. So this is how this will look. So when you click, all the user sees is something like this: open in non-vulnerable insecure version 2, and then you have cancel or open. So if you tap on open, then you will get this success making the call, right? So this is a very interesting attack because it calls phone numbers, and this can be a serious issue in the mobile environment due to the possibility of making the app ring premium numbers, right? So the attackers can monetize the attack more easily. So now it's our time to the demo. So let me show you. Now, of course, since you have access to the slides and the apps and everything else, you can try this on your own later. So this is why this is not just a webinar, but also a workshop. But since we only have 1 hour, I'm just rushing through this a little bit because we still have to talk about XSS, which I think you will like a lot, right? So this is the non-vulnerable insecure app application, and I'm now opening Safari, and here I have this page. So if I tap, I'm just making this bigger because I have fat fingers. So if I tap on the first link, you can see I'm getting this success. So I'm now hitting OK. And now if I go back to Safari and I hit the second link, you can see that I'm also getting this success, right? So I'm closing it, then I go to Safari, and when I do it, every time I do it, the phone call is made, right? So this is how this works, right? So very interesting. It's a relatively simple attack, but it's a quite effective and interesting attack, There's another, if you go to the store, there's also a free workshop called Practical Mobile App Attacks by Example. And in there, in the slides, I show you another very interesting scenario where there was an application looking for an update, and then the update, because this check was done using cleartext HTTP, the update URL was changed to a phone number, And then when you tapped on update application, instead of updating the application was ringing a premium phone number, right? So this is another way in which you could pull off an attack like this, right? So pretty cool. So now let's talk about XSS. So XSS attacks and data exfiltration on Android and iOS. So let's talk first about Android. So WebViews and data exfiltration in Android. Now, WebView is basically a small browser inside of the application. So, in principle, if the WebView is configured insecurely, it can have as many permissions as the app that includes it, right? So this is if the WebView is not locked down properly. So you can, it can enable JavaScript, it can enable loading local content, reading local files. So lots of things like this can be enabled. Now, in old versions of Android, all the insecure settings were enabled by default, but with the pass of time, because all security researchers, reported all these things, now by default things are a lot safer in Android. But developers can still shoot themselves in the foot by enabling all these features uh, to to have vulnerabilities like the ones that I'm going to show you now. So yeah, and another thing is that native Android functions can sometimes be accessed from web views, right? So in the case of Android, there's these JavaScript interfaces. So there was a bug about this that was fixed in Android, but depending on what the JavaScript interface does, this could still be a problem in some cases, right? If you expose too much, you can, with an XSS, you could still invoke some Android functionality, and things could get nasty there as well in some edge cases, right? So this is not very common. So what can you do with XSS on a web view, right? So one thing could be HTML injection. Now, in some cases, this might be, especially nowadays, this might be the only thing you can do with HTML injection. But even though it's only HTML injection, it can still be enough to do damage, because with HTML injection, you can, for example, show a fake login page that points to an attacker website. So because on mobile devices, you don't see the URL, things need to be pretty, there's pretty much no space to see the URL bar and all things like this. If you can get a nice HTML injection that shows a believable login page, you can use that to, for example, capture credentials, right? So even if it's only HTML injection, it can get bad, just to say that. And then with XSS, we can do a lot more. Of course, we can change the page, we can invoke functionality from JavaScript, and so on. Now, in some cases, we can also do data exfiltration of local files that I will show today. Of course, this is going to depend on the security context and the web view settings, but it is possible. And if we can also do user impersonation using cross-site request forgery using XSS, depending on the application, right? So if you have XSS, it might be possible as well to send requests to the website or read cookies or do other things like this. And with that, you can get a much higher level of impersonation. Now, again, there's a lot of examples like this in the free workshop that I mentioned before that is available on the store, Practical Mobile App Attacks by Example. So almost 4 hours, that workshop. So, okay, so let's talk about data exfiltration in Android. And for this, we will use an application called AndroGoat. Don't use the official one because we had to change it. So the one in the training portal is modified to specifically show this exercise with data exfiltration. So the official one will not work for this. So just get the one from the training portal. So again, you log in, and from the slides, click on this link while you're logged into the training portal, and this will download the APK, and then you can follow the exercise from there. So first we need, because we want to do data exfiltration, right? So we want to delete some files. We need to, so we need to, let me see. So we need first to create some files to steal, right? So we install the APK and we want to demonstrate stealing files, but first we need to create some files to steal on the application. So for this, we can go to the insecure data storage menu. So this is how it looks. I will show this in the demo as well. So you open the version from the training portal Android Go, and then you go to insecure data storage. And now there's two things. One is to create a shared preferences file, and then the other is SQLite. Right. So first create a preference file, and then you can put like my secret user and my password. So shared preferences part one, you enter your username and your password and hit save, and then create a SQLite database file. Right. So you go to SQLite and then my user and then the password and hit save. So this will create an XML file for the preferences and a SQLite file for this user, right? So in here, from this, now we can navigate to the input validation XSS. And if you have followed this entire exercise, don't forget to delete this file on the SD card, right? Because there's also a nice scenario about it. So in here, go to input validations and then input validations XSS. And now we will need to look for HTML injection, right? So you can insert like h1 and hello, and you will see that there's a bigger hello. You can do image or text on error alert 1 or script alert 1, and it will show you the alerts. You can then do, okay, I have XSS, but what is the security context in which this XSS is running? So you can do alert location, and this will show you the place where this XSS is running from. So in this case, because we have a file context, this is very interesting, because from a file URL, we can probably read local files and send them to an attacker. Right? So in this case, we have two XSS access to demonstrate. So one is on internal storage, which is protected from other apps, and the other is on external storage, which is a very bad place to load HTML from, because other applications could, for example, write in this HTML and get XSS, even if the application wasn't vulnerable to XSS, just because the HTML is loaded from an untrusted location. The SD card is a place where all the other apps can write and modify files, right? Now, for data exfiltration, we need to figure out the paths. So if your phone is rooted, you can, well, if you follow the exercise, you know the paths. But you can do like ADB shell, and then you navigate to this. So data OWASP at agoat, and then share preferences user.xml and databases agoat. So these are the two files, right? So this means we have two URLs to fill data, right? So one is data, and then share preferences users XML, and the other is similar, and then at the end we have agoat. So in both cases, we can insert this script, and then this will read the local file and alert it, demonstrating that with the XSS we can read the file, and then in a real attack you can also like send this to a third-party website, like an attacker-controlled website, and that would complete the stealing, right? So you can do this by inserting the field, and then you hit display, and you will see the credentials, right? My password, my secret, and so on. So that's how that works. And then it's important to know that this is not limited to application files. So anything else that the application can read, you could also steal. Like for example, if the mobile app has access to the SD card, you can also read anything on the SD card, as long as you know the path, right? So yeah, just don't limit yourself to application files. You can also read from the phone, right? So for example, in a real phone, I could read like system etc custom conf, and you can also read files from other apps if they have permissions that allow this. Like this file from browser has permissions, and it can also be read, right? So this is an example of reading these files from an Android 9, right? So in summary, we can exfiltrate application files from the vulnerable apps, system files, as long as the application has permissions to read that, and files from other apps. We can also read any SD card file, right? So methodology-wise, you're looking to answer these questions, right? So can we, first you check if there's HTML injection, and you can see that there is. Then you can check, can we run JavaScript? If you get the alert one to pop, that is a yes. Then what is the security context in which the XSS runs? So you can figure that out with alert location. And if it shows you file, then that's a privileged context. So it means there's no same origin policy protection. So we should be able to read local files. And then we can say, okay, if those things are the case, then can we read local files? So you can try to read some of the files from the application, and we confirm that this can be done. Then another possibility is XSS through SD card manipulation. So because the file is on the SD card, we can also like go to the SD card, change the HTML file, and get the alert to pop out immediately, right? So you can navigate, find the file on the SD card, and then you could do ADB pull, change it on your computer, and then you do ADB push after inserting some HTML injection there, some XSS, and then that will give you persistent XSS just because the HTML file was loaded from an insecure location, the SD card. Right, so input validations XSS, and then when you click on it, you will get the alert immediately if you do that part of the exercise. If you use MobSF for analysis, you can sort by time because it does this like by hash. So by doing ls-lt, this will sort by time, so it will give you the most recent scan at the top, and then inside of there, you can copy those files and you can change this hash to just decompile to give it a little bit more sense. And inside of there, you can look for external storage to try to find the issue, right? So since we're running a little bit short on time, the issue here on the XSS is that there's a DOM XSS vulnerability. There's this document.write on user input. So that's the XSS. Then you can keep looking for, okay, where is this HTML file? And this will point you to the vulnerable activity. Inside of here, you can see all the secure WebView settings that make this possible, right? So a developer can enable this, and then this kind of attack can work. The other thing is the file URL. You can see there's a load URL of a file URL. So this is another red flag. So some recommendations, if possible, use TextViews. In TextViews, you won't have XSS because they only allow text. If you have to use WebViews, try to disable JavaScript, try to disable file access, and all those other things. Then output encode user input prior to rendering it on any web view, and then avoid DOM XSS syncs as much as possible, or otherwise sanitize user input prior to assigning it to a DOM XSS sync like inner HTML, location, href, and so on, right? So if you look at the OWASP XSS prevention cheat sheet, it has a lot of details about this. So with this, let me do a quick demo about this. So for this one, I need to open AndroGo. So I just go here to AndroGo. First, we need to move this somewhere else. First, we need to create some files. So go to Insecure Data Storage, Share Preferences Part 1, and here I put my username and my password. And I hit Save. So that's the first part. Now I have to go back here. And now go to SQLite, and here my SQLite user and my SQLite password. Hit save on this. So now the data is saved, and now we can go to the actual XSS vulnerability because there is data to steal, right? So we go here to input validations XSS, and inside of here we have these fields. So since we are a little bit short on time, I'll just try all the payloads at once, so that we still have time to cover iOS. So yeah, I'm just going to copy all this. So you can copy all that and then go back to here and just paste this. And then now I can explain what's going on, right? So here we have the hello that is bigger. So this is the HTML injection. This is the alert one. So we have JavaScript execution. This is the alert location, so we can see this is being loaded from a file URL, which means there's hope for exfiltrating local files. This is actually reading the preference files, so you can see my username and my password. We can read the user credentials using this XSS. This is the HTML. The XML, sorry. And here we can see that we can also read the SQLite database, and we can see the credentials here, like my SQLite user, my SQLite password. So the credentials are visible here, right? So yeah, this is some examples. This is the binary from browser, so we can also read files from other applications as long as we have read access. And I think that is pretty much it. So that is for Android. So let me now show you the equivalent on iOS. So on iOS is pretty much the same thing, right? So we will use them vulnerable insecure. So go to web issues and start challenge. Here we enter the payload on the top menu. So you can do the same thing like hello with each one, image, for text owner alert one, alert location, and then try to read local files. So in this case, we can try to read the cellular usage and other files like this from the phone. So this is how it looks. So we are trying to answer the same questions. Do we have XSS? Where is the XSS running from? Can we read local files? The answer to all this is yes. And to look for these kind of issues, you would grep for WK WebView and UI WebView. So these are the two main kind of web views in iOS. So you can grep through this to the on the source code, try to find the vulnerability. And here we can see the vulnerability in this string concatenation. Now the syntax highlighting here is not great, so you cannot see that name is actually a string concatenation in Swift with this backslash. But here you can see in Xcode, if you open the same file, you can see that name is a different color than the rest of the string because this is a string concatenation. So this is the vulnerability. And the other part of the vulnerability here is that this is using a UI WebView, which is more insecure by default. And also there is no URL. So if there is no URL, if base URL is nil, this means we can also exfiltrate data, right? So so this issue is possible due to the fact that WebKit allow universal access from file URLs and WebKit allow file access from file URLs. These two insecure settings are enabled by default on UI WebViews, which are the old WebViews, but a lot of iOS developers still use it. And these settings are disabled by default on the WK WebView, which is newer, faster, and more secure by default, right? So you should always try to use WK WebViews if you are an iOS developer. However, you can also misconfigure a WK WebView to enable these insecure settings, and then you would also have these types of issues. So let's do a quick demo about this before we wrap up. So here we have to, I'm going to move this a little bit here to the right. So we have to tap on the menu, and then we scroll to Web Issues, Start Challenge. And here I'm just going to open Safari. And what I want to do is just copy the payloads from here. Now you can click on the link from the slides and open it on, this is something else. So I'll just copy this. So now I can go back here and paste the payloads and hit return. So now we can see all this, right? So here we can see this about null, right? So there's no URL, and we can see Apple Web Data. So Apple Web Data is a sensitive URL because it's a URL that is more privileged. It's kind of a file URL. So this means that if this is a UI web view and the URL is Apple Web Data, there is hope to exfiltrate files. Also note that in iOS there's these random IDs. And this is giving the ID away, right? So you can, using this ID now, you can probably like read some local files that use this ID as well. This is the alert one. Now this is reading the phone call history, and this is reading another SQLite file, right? So this is just demonstrating that we can read local files. So yeah, I think with this we are pretty much done. So yeah, now it's time for questions. I would also like to mention that there's more free workshops in the store, so you can tell your friends to go there to the store and get any other store. Now, some people were confused about the personal discount and referral link, so I created a quick YouTube video today about it. So you can see that. Let me just paste all this on the chat. And just to mention that there's a live training next week, right? So let me paste all that so you have all those links. Now I'm just going to go back to answer your questions, right? So let's see. Your voice is breaking. I hope you could all hear me fine. I'm not sure if that's a problem with your connection, or I hope everybody could hear me fine. If not, there's also a recording on the training portal. Okay, can we get the link for all PDF mentioned in the slides? Yeah, well, I mean, you have the slides, so you can see all the links there. Okay, is there an easy way to grab the app manifest on the device, or do you need to grab the APK offline and decompile? So there's a lot of ways to get the APK from the device. In the course, we cover some techniques to do this, but also there's a free application that you can get on Google Play that you can use without root or anything, and it will give you the APK for any device. Another question, I've just checked the 70 Security website. What are the charges for this complete Android and iOS training from scratch? I can see the price on the website. The prices are on the store. So if you just go to the store, the links that I just pasted in the chat, you can see them there. But again, you all have this discount code that you can use, right? So it's all $100 less than whatever you see. It looks like an old vulnerability found in Skype. I was able to call via Deep Link. Yes. So a lot of applications are actually vulnerable to stuff like this. So you mentioned Skype, and in the course we have Periscope and Shopify. So they are all very, high profile and widely used applications. So yes, a lot of well-known applications have been affected by this. Can anyone share the complete price of mobile app pen testing? You can see it on the website, on the store. Yeah, so this is the link on the store. Having an issue logging into, if the issues to logging, I will investigate after the webinar. Let me just copy this. I'll try to find you. So this is Sam. So I'll try to find you. But the best is if you email admin@70security.com, then we will be able to investigate this better. So I'm just copying that so that I don't forget about it. I'll check, try to find you after the session. Package here, yearly package. UI web views are deprecated and are no longer accepted in App Store, and that is nice. Yes, but there's still some applications that use it. Okay, so these are the links that I sent, and let's see if there's any more questions. Great explanations. I can hear you okay. Okay, so thank you for all the nice feedback. Okay, so if somebody was able to hear everything, then it was not my problem. It was the problem of somebody's connection. Do you know any public reports about vulnerabilities related to deep links? Yes, there's a lot on the internet. I'm not sure if in our public reports there's something about this, but in our practical what was it called? Practical mobile app attacks by example. This workshop that is free that you can also get to the store through the store. You have a lot more examples from real Pentest, and of course, I mean this is all anonymized because they are like applications from clients and stuff. But you can see a lot of cool attacks. So, for example, in that workshop, there is one very cool attack where using a deep link, you have like a SQL injection on the mobile app, but at the same time, the SQL injection was a remote code execution because you could get through the SQL injection, you could load the library, right? So definitely, if you're interested in this, definitely watch the practical mobile app attacks by example workshop. It's also pretty cool. And it has a lot more examples with deep links and so on. I work with Drosser and ADB a lot. You can see the cheat sheet. Yeah. So Drosser is pretty cool. Awesome. Okay, so it seems there's no more questions. I went through all this, so I'll see you next week for those of you coming. I sign up for the other free workshops. How long before they show up in the profile? They should show up immediately. If you don't see them, try to do shift plus refresh, because I think the caching headers are a little bit aggressive. You can also try an incognito fresh incognito session browser. So try fresh incognito browser session, and that will definitely get rid of the caching. This is because the caching headers are a little bit aggressive. We're trying to fix that very soon. But yeah, it should appear immediately as soon as you get any of the other free workshops. They should appear there. Yeah, and any other questions, feel free to email admin@7esecurity.com, get any of the other free workshops, and if you are interested in joining the training next week, you have a YouTube video explaining you how to find your own discount code for now. We'll try to make this a little bit clearer in the future because some people were asking about this. And yeah, thank you for coming, and I hope this was entertaining and useful. Have a nice evening. Good night.